Hello everyone, how are you? Now today I will show you how binary search algorithm is implemented, or how we find required target value or key from a list of arrays or a list of items using C++ programming, just by taking sample example of list of arrays and searching an element that is found from the list and an element that is not found from the list. So the implementation technique is using binary search algorithm. So basically, as introduction, so what is searching mean? Searching is the process of finding an element from a list of items, or that determine the item is not found or not found. Is the item found from the list or not found from the list? If it is found, where it is found? At which index is the required target or the required key is found from the list. So using this way, or to do this way, we use binary search algorithm, the second type of searching algorithm, simple searching algorithm, which is called binary search. So the searching algorithm, or the method, or the binary search works by assumption, dividing the array list or the list of items or the collections dividing into two. But basically the binary search algorithm is only applicable for sorted items or increasingly sorted list of items or elements. So if your array is not sorted, or if your array is disordered, first of all, your task is to sort the array by using either selection sort, insertion sort, simple sort, or selection bubble sort algorithms. After you sort the disordered one, you can apply binary search algorithm. Unless and otherwise, for disordered sorts, binary search is not applicable. So by default, assuming your array is in increasing order sorted, like this one. Assume this is a list of arrays in increasing order. The array may contain, assume 5 elements, 3, 5, 6, 8, 9. This is the given assume list of arrays. Assume list array list is equals to this value, and the index is 0, 1, 2, 3, 4 by 4. So the list is already in increasing order, and for the function we pass two parameters. The first one is the array list, and the second one is the required target key. The required target key that we find from the list. So how it works? First, the search or the array is divided into two by taking what? By taking the lower bound is equals to some value, in this case 0, and upper bound or top bound is equals to the top array of your value, or in array context the top bound is n minus 1. In our case, n is equals to 5. N is equals to, that means 1, 2, 3, 4, 5 elements. We have 5 elements, that means n is equals to 5. So the top bound is n minus 1 is equals to 4. So how it works in binary search algorithm. First, calculate the mid index of your array. So mid is equals to mid index is equals to what? Mid index is equals to lower bound plus upper bound over 2 divided by 2. Taking the average is equals to, in this case, mid is equals to mid index is equals to what? Mid index is equals to lower bound is 0 plus upper bound is 4. See, divided by 2 is equals to 2 is equals to 2. Then after we got the middle index value of our array, check the value of the middle index is equal to our record key target key that we want to find or not. So in this case, list of what? List of mid index is equals to what? The required target, which is the key. The key here, if it true, if this condition, if condition is true, if condition is true, your search is in or over here, in this over here, because the middle value is, let's assume the middle value, the key, if we find 6, list of middle is 6, the required target is 6, then 6 is equal to 6, it is okay or right. So searching is a searching mechanism in this here. So in practical more and complicated worst searching mechanisms, that means if the required target is found at 9 at the end or at the top of your array, how we search and apply binary search algorithm. Actually, it is better to write sample functions how to search the required target and see it how it is implemented. Okay, guys, just we see here how the program is perform or achieve the required task or the required key is found at ith index. So what we need to do is next is that first we declare the binary search. The function takes two parameters. The first one is the list of arrays, and the second one is the key that we want to search from the list or from the array. And we declare the size of the array to calculate where is the top found, and then using leave it. Just this is the main method. To just directly pass to the function. How the function performs this task. So int binary search, int list of the array, and int key. So we pass two parameters or the arguments to our function. The first one is the list of arrays. The second one is the key that you wanted to search from the array. So initially the first time found is 0. That means where is the item is found, or the item is found or not found in the list. We didn't have any information. So at the beginning, found is equal to 0 and index is equals to 0. And the top element or the top index of the array is n-1, which is based on your array index. So assume just we have if we have an array of 5 elements containing 5 elements. As I told you before, the array should be sorted order, so 2, 5, 7, 8, and 9. Then the index is 0, 1, 2, 3, and 4. So from this, n is equals to 4. That means, n is equals to 5. And the top value is n-1 is equals to 4. So giving each value found 0, index 0, top 4, bottom 0, and the middle is not known. We now by calculating the top plus the middle, the top plus the lower, dividing by 2 can get the middle index value. Then here found f is equals to 0. We can say f found index is equals to 0 as the first time. Top is equals to n minus 1 is equals to 5 minus 1 is equals to 4 at the first time, and middle is equals to top plus lower boundary, or bottom, we can say bottom. Actually here bottom is equal to 0 as the first time. The bottom means the beginning of the array, or the first value, or the first index of the array is equals to 0. Therefore top plus bottom of your array divided by 2. We can get the middle value, which is top is 4 plus 0 divided by 2 is equals to 2. 2 is the middle value. Just assume if we are looking or searching the index of 8, that means when the key is equals to 8, just we wanted to search the index of 8. Where is 8 found? If found the index. If it is 8 is not found from the array, return not found. So the function returns which index are there found. So now here at the first time, middle is equals to top plus bottom over 2 is equals to 2. 0 plus 4 over 2 is equals to 2. Then next what here do? Check your array list. And if the array is found, go ahead. Unless what we do from this, if this value key equal to list of middle, that means your target key and the values found at the middle index of your array is matched or the same. Found is equals to 1, and the do while statement is turned out from the loop. Unless if this statement is not true, the else statement is continued. That means if is not satisfied, the else is also executed here as another option. Then what we'll do, if key less than list of middle, key less than list of middle, that means key is the required target. That means here 8. Less than list of middle is here in our case. List of middle meaning list of, assume this is the array. The array name, and list of 2, middle is 2, list of 2 is equals to what? 7. List of 2 is equals to 7. Check. List of 2 meaning 7. 7 here 7 equal to 7 is 8 is the key. 8 equal to if 8 equal to list of middle meaning 7. Is this true? If condition. If this true, the target is found. But unfortunately, this is wrong. 8 is not equal to 8. 8 is not equal to 7. So what you have to do? Go to the else statement and check this one. What will happen? The key is greater than the middle value or not? The middle value is 7. So if 8 greater than the middle value, go to the forward direction or the right way or above the middle. If the key is less than that of the middle value, back to the previous or the lower bound of your array or the lower half of your array. Lower half meaning to this direction. Lower half, upper half. So what? Next one, check this one. Unfortunately, if the second condition, if key is 8 less than list of middle meaning 7, is this true? No, wrong. 8 is not less than 7. So this statement is not executed. The next one is executed, the else one as you see here the else one. So what you have to do? Bottom is equals to, top is equals to, bottom is equals to mid plus 1. change here, come to here and change the bottom value. At the beginning bottom is 0. Now at this time bottom is middle plus 1, middle is 2, 2 plus 1 is 3. Middle plus 1 is 3. Then what is to do next? Also check the top value. Check the top value. By default, the top value is take as it is. Take as it is, or pass it as it is. And what here we do is that while found equal to 0 and top greater than or equal to bottom, top greater than or equal to bottom, do if this statement is true. Still the key is not found. The key is not found. The key is not found. Therefore, and the top is 4. 4 greater than or equal to bottom is 3. True. Then back to the do statement and check again. Check again. Middle is equals to top plus bottom. Middle is equals to top plus bottom. Top is what? 4. Still now not changed. Still now not changed. Top 4 plus. What about the middle? The middle is here 3. 3. Middle 4 plus 3 over 2. 4 plus 3 divided by 2, which is 7 over 2, 3.5. We only take the integer 1, that means 3. That means 3. Therefore, the middle is 3. The middle is 3. And take the middle value second time 3. And what we have to do is that next one, the next step is check the condition again. If the key is what? 8. Well, found searching is 8 found in the list or not. Therefore, 8 equal to list of middle. What is middle? 3. List of middle is what? Search from the list 0, 1, 2, 3. List of 3 is 8. Therefore here list of 3 is equals to 8. Then 8 if 8 equal to 8, this is statement list of middle meaning 8. This is true. Then what we have to do? Found is equals to 1. Set found is equals to 1. At the first time found is 0. Found is 0. Change it to 1 because this statement is executed or true. Then the next statement of the if is executed. Then found is equals to 1. If found is equals to 1, the else if is true, else is not executed here. The first option is true. The second option in the else statement is jumped and go to the while loop. Go to the while loop. In the while loop, as you see here, in the while loop, found is equals to 0. Wrong. No. Found is changed to 1. So what is to do? The remaining condition is not necessary to check. Why? Because in the while loop, the operator is logical AND operator. Then in logical AND operator, the first statement is false. Whatever the second statement or the second condition, this also makes the entire while loop while condition false. Therefore, the do statement or loop is turned out and go to the end. Therefore, if found equal to 0, wrong, aim, salam, jump, index is equals to the minus 1. If this is true, index is equals to minus 1. Unless found is 1, as I show you here, found is changed to 1, found is because the if statement is true here. The if statement is true here. That means where it is key is matched to the middle elements of the list, the third index of the list. Therefore, found is changed to 1. Then inside the while loop, the first if statement is not executed. Why? Because found is already false. Therefore, we'll turn out from the loop, and the next statement is the if. When check is this one, found equals to 0, wrong. If this statement is wrong, the next statement is not executed. Then the another option of the if is the else one. Therefore, index is equals to middle. The index is equals to middle. Index is what? Index is 3. Middle is 3. Therefore, index is equals to 3. Index is equals to 3. Then what will to do? Return the index. Therefore, when we get the 3, list of 3 is equals to 8. Therefore, at the third index of the list or the array, our required target key, which is 8, is found. This is how binary search algorithm is implemented or performed or work. This is how binary search algorithm is implemented. Good. Unfortunately, if the key is not found in the list, what will happen? Just like 10, if the list is 10, or the required target key is 10, the required target is 10, what will happen? See this in another way. So we check it again where in the if clause, in the if statement here. Here what we have to do, mid is equals to top plus button. Before that, we check this one. Actually, if the middle value, the required key is 10, list of middle is 8. Therefore, 10 if 10 equal to 8, false. Therefore, if this statement is false, found equal to 1 is not executed, then the else option is executed here. If key less than list of middle, no. Else, if this is true, top is equals to middle minus 1. But unfortunately, the key is larger than the middle value. Therefore, else is equals else in the else part. Bottom is equals to middle plus 1. Bottom is equals to mid plus 1, which is the mid is 3. 3 plus 1 is equals to 4. The bottom is 4. Then inside the while found is equals to 0. Yes. And top is equals greater than or equal to bottom. Yes. Top is what? Top is 4. The bottom is 4. Therefore, 4 greater than or equal to 4. True. If the required target is maybe found at the end or the last index, this condition should be satisfied or may satisfied. Actually, this condition is true by in this way. So what we have to do? Go back to the do while loop. Go back to the do while loop here. Go back to the do while loop and what we have to do? Middle is equals to top plus bottom over 2. Middle is what here? Top is 4. Middle is equals to mid is equals to top plus bottom over 2. Top is equal to 4 plus middle is also 4. Divide by 2 is equals to what? 4. 4 plus 4, 8 over 2, 4. Therefore, check this one. If key equal to list of middle, key is 10 because we changed to 10. If we wanted to search, 10 is found in the list, and if it is found, where it is found. If it is not found, return minus 1. So 10 equal to list of middle. List of middle meaning list of what? List of 4. Middle is 4 now this time. Therefore, list of 4 is what? 9. List of 4 from the array is 9. Therefore, 10 equal to what is to do? 10 equal to 9. If 10 equal to 9, that means this statement. No, 10 is not equal to 9. Not equal to 9. Therefore, this statement is false. We jump to the else one. If key less than list of middle, less than list of middle, false. Key is greater than middle. Therefore, this if statement is not executed. Just pass to the else one, another nested else one. Bottom is equals to middle plus 1. The middle is what? Bottom is equals to middle plus 1. Middle plus 1 is equals to middle is 4. 4 plus 1 is equals to 5. Bottom is 5 now. And now here in the else in the while statement, found equal to 0. Yes, still we didn't get the target key is found in the list or not. Then therefore found is still not changed to remain 0. Therefore top greater than or equal to bottom. Top is what? 4 here. top is 4, not changed still now. 4 greater than or equal to bottom. Bottom is what? We calculate new value 5. 5. Is this condition true? False. Therefore, if the condition is false, the entire while condition is false because it is connected using the end operator, logical end operator. Therefore, the do while loop is turned out from the loop and goes to here, goes to the first statement of the next to the while loop. Therefore, if found equal to 0, yes, we didn't get the index of the required key. Therefore, index is equals to minus 1. Index at the first time, index is 0. We changed it into minus 1. Index is equals to minus 1. Else is not executed because the if is true, the else is jumped. And what we have to do? Else didn't have the brace, therefore this statement is jumped and this statement is executed. That means return the index. Return the index. So where is the, what is the index? The index is minus 1. So when we run it, this program, using nemesis session, enter the list of arrays, assume the program accepted list of arrays from the user, and again see in the key what you want to search from the array, and enter the key using for loop. We accept it, and then int I is equal to binary search list comma k. List is the array. We call the binary search function. List is the array argument, and k is the required key target integer value. Then if I equal to minus 1, that means the index equal to minus 1. See out the search item is not found in the list, as like that of this one. From the list of arrays, k is not found. Yes, in this scenario or in this situation, this condition or this line number 80 from the code is executed. Else, if this index equal to minus 1 is not true, that means index differ from minus 1 or equal to 1. See out the values found at index position like that of the previous one. So binary search algorithm is implemented, looks like this one or in this way. Guys, please like, share, subscribe. አሁንም ማሳያችሁ ከቲዮሬቲካል አስፔክቱን አሁን ያወራነውን ራን ብናደርገው ምን አውትፑት እናገኛለን የሚለውን ነው ማሳያችሁ። ስለዚህ ይሄ ሜን ሜተዳችን አለ። ይሄ ደግሞ ፕሮቶታይፕ ኦፍ ዘ ፈንክሽን አለ። ኤን ሳይዝ ኦፍ ዘ አሬይ ዲክላር አድርገናል። ዩዚንግ ኔሴሲቲ ኢንቱ ሜን then this is the list of arrays that we want to pass to. We create n size array and n is 5 now, and declare another value variable called k, which is the key was that we wanted to search from the list of the array. See in the key ኪውን አስገቡ የሚል ሜሴጅ ዲስፕሌይ እንዳል ኪውን እናስገባለን። then continuously arrayውን 5 size ያለው array እናስገባለን ማለት ነው። Then using this for loop, and after that we call the binary search function here. The binary search function takes list of array as a parameter and the key that we want to search, and this is the binary search function. As I told you on the board, initially found index. Top bottom is the initialized and the middle is not initialized because we can calculate the middle value by taking the average of the top plus bottom over 2, and then inside the do while loop just top plus bottom over 2 middle, and check the key is found at the middle of the list. If the key is found at the middle of the list, the game is over here. Found is equals to 1, the end the game. Just end. How it ends? Check found is equals to 0. No, because found is changed to 1 here. Then the while loop is not return back again.
terminated here, and if found equal to 0, no, again index is not equal to -1, therefore middle is equals to index is equal to the middle meaning top plus bottom over 2. That means the value of the key were found it. But if key is not found in the list list of middle, this statement is not executed, then directly pass to the else one. And in the else statement, the some modification here, check key is less than or greater than the list of the middle, either to the left or to the right of the middle, if the key is where it is found. If the key is less than list of middle, top is equal to middle -1, and the else statement is not executed here, just directly pass to the while loop and go again to the do, calculate the top again in new way. In this way, the binary search algorithm is work or is executing or searching the target key. So when we run it, enter the key you wanted to search from the key array. Just for example, I wanted to search 8, enter list of arrays 5 element, enter 1, 5, 8, 9, 40. Assume this is the list of arrays. Enter the values found at index position 2. How? List 1, 2, 3. The third index is equal to the key that you wanted to search. Therefore, the required key is found at the second index of your array. This is how binary search algorithm is work on data structure and algorithm. Thank you for today's video. Please like, share, subscribe.